this way, and then you gotta like do this with drawing, you know? I mean, it's like, oh, it's really hard. Yeah, you gotta. Okay, the test. Here's the data on the test. The printer ate one of the pages, so it was a little shorter than. Yeah. The printer. So I left that to your guys' benefit, and I just made it out of 80 points, and then I curved it to a percentage, so it's out of 100 points. If you go into handout and lectures, chapter 3, and scroll to the bottom, it will have a blank exam and the answer key, and I left the blank exam like it should have been. So this is the page you guys missed. And the answer key is also posted there with the page you guys missed. So overall, I don't really think it affected the outcome. I still gave you a 3-point curve like I would originally, even though it turns out there's only 79 points on the test because I lost that page. But then I made it out of 80 points, so you got a bonus just for saying putting your name on it. I'll go ahead and pass out the test, and then I gave you a 3-point curve on top of that for that. Just because originally you were going to get 3 bonus points for the test anyway. So out of 80 points, that's why you could get 103.75. So you got 60.63%. It's because it was out of a weird number to begin with. So I also have some quizzes to give back to you. So I'm going to try to pass some of these out. We'll go over a little bit of this today. Amy, 7, Marcus, Peyton, right here, Tony, Brittany, access, yes, Brittany, Kristen, no, I just couldn't do it. I have a Christina, Mike, Will, Christopher, Sarah, Tiffany, Amy, 7, Peyton, I'm sorry, your places, Tony, Brittany, Letterman, Paige, Mike, Will, Christopher, Sarah, Tiffany, Kevin, Will, Peyton, Tony, Casey, Sarah, Tony, Sarah, Devin, Tony, Tony, isn't that all? Kevin, Amy, Brittany, Sarah, Amy, Brittany, Sarah, Casey, Sarah, yeah. I'm gonna go ahead and give you guys today before I go over the test. Okay. The average 75%, the median 73%. Really kind of the median means that half the class got above a 73, and the average is if I add up all the grades and divide that by how many grades I had. I think it's pretty evenly distributed. Either people knew it or didn't. It was really hard on that 11-point problems. If you have nothing, really hard to kind of give partial credit there. So we look at the exam, which is also posted to Blackboard. Download it. It's going to look a little better. Let's see if I can zoom in here. Number one, most people got all the points. If you missed points, it was probably because you didn't have plus or minus 3 as a factor. Some of you just took the square root of 9 and said 3. Number two, and I'm sorry, the scanner didn't really show up very well. X-intercepts and Y-intercepts, some of you factored out a minus X, but didn't actually factor out the minus X, so you got a -4 and a +3 question. What? Oh. So it's worth 8 points, so everything was worth 2 points, so it was actually a -3 and a +4, and then a 0, so 1, 2, 3, 4, 5, 6. Again, it's kind of hard with some of these. Far as partial credit going, sometimes, like this one, it's hard to give partial credit because you just kind of have to see it. The same thing with number 3, the in behavior, all I kind of care about was the arrows, and most of you did that fine. We had those 6 points. Number 4, it was already factored. So the in behavior was worth some points. The zeros were worth points, whether it touched it and went away from it, if you knew it was a multiple 0. I was flexible if you labeled y = 12, even though it kind of said clearly show the x-intercept and the y-intercept in the in behavior. Most of the time on this problem, it was everyone got all the points or they missed at least 4 points, just depending on the setup. It doesn't have to look like this hump. It could be smooth. Again, people got all the points or they missed more than half the points because it was the in behavior was worth credit, and then the zeros worth credit. Multiplicity of the zeros were odd, so it would go all the way through it. Some of you tried to like touch it, go away from it, and then cross at a different point, so miss points there. This is the page you guys didn't have. Well, not too much news. Synthetic division to show the remainder. You guys had to do that on number 9. So really it was tested, just maybe not as much as I wanted it to be tested. We talked about using synthetic division to find the value of the function at -2. So do synthetic division, the remainder is the value of the function at -2. I didn't get to test that, but it might come up on the final exam, so be aware of that. And then using synthetic division to say if something's a factor. Again, that was kind of tested on number 9. I told you it was a factor. Here you had to make the conclusion that it's not a factor. So some people missed number 9 because I said show the remaining zeros, and you just showed me that it was a factor and didn't actually go through. It turned out they were imaginary, so that might have taken some. I was pretty flexible with the way Sometimes some of the students wrote it. If you got down to this point, then I was okay with it. Some of you put the square root of 2 or something. That was maybe, I don't know. So again, this is really not a college algebra question as far as can you do the quadratic formula, but can you come up with another factor? And it turns out it's imaginary factor, which would be a Math 110 type question. Number 10, most of you got this, no problem. I think some of you didn't quite understand what it meant, and so you tried to do some crazy stuff. I forgot my calculator. Well, you don't need a calculator, but I don't know what, if you were trying to find the zeros or something. You don't need the zero. You don't need to find them. You just need to find all possible rational zeros, but not actually find the zeros. Number 11, pretty straightforward. Some of you switched vertical and horizontal asymptotes. Which one was vertical, which one was horizontal? So you lost some points there. Most of you got it, no problem. The kind of big ones on this test was 12 and 13, and that had to do with graphing. I tried to break it down kind of point per point. So if you get the horizontal asymptote, if you get the vertical asymptote, if you get a 0, if you get the limit, or that as the function approaches this vertical asymptote, it goes up. As the function approaches it here, it goes down. If you kind of, each thing was kind of worth a point here, a point here, a point here, and a point here. If you had nothing kind of there, it was really hard. I mean, it was minus 11. So that got some of you guys. Question?
I had a hellish time.
With this one?
This one, yeah. I got the asymptotes, but I don't know why I couldn't graph it.
So
Did you just
yeah, so a lot of you didn't have this kind of this the sign of the function, and that tells you that above the x-axis or below it. So if you have a horizontal asymptote, then you know you cannot cross this horizontal asymptote, right? So if I'm below the function, but I know I have to cross the x-axis at this point, I know this is my only choice, right? Let's see if I can comment on it here. I apologize for the quality of the scan. I'm going to probably try to rescan this in and give it to you guys in a better. Okay, so if I have this function, you could always plug in points, and some of you did that for this area here.
I tried to, but I was wrong.
I think you had this point right. If it was you. No, okay.
It was everything.
So yeah, if I plug in x equals 0, it would give me minus a half. So I know this point is on the graph. It's a y-intercept. If I set the numerator equal to 0, I get that at x equals 1. So I know that. I know I cannot cross this horizontal asymptote, and I cannot cross this vertical asymptote. So if I test the sign of the function from minus infinity to 1, I'm either always above the x-axis or I'm always below it. And it turns out I'm always above it. I'm always below it. My function's negative. If I plug in 0, I get minus a half. Means I have to be below the x-axis the whole time between minus infinity to 1, but I'm approaching this horizontal asymptote. Right? And then from 1 to 4, I'm positive. So if I plug in 3 into this function, I'm above the x-axis. If I plug in 3, it gives me a point above the x-axis. So my only outcome is to go up and go to infinity as I approach the vertical asymptote. Then if I plug in 5, if I plug a number on the right side of 4, my function is below the x-axis, it's negative. If I plug in 5 here, I have 10 minus 2, which is positive, and I have minus 10 plus 4, which is negative. Positive over negative is negative. So it tells me I'm negative the whole time, and that's my only option. It could look something totally different. It could be whatever it wants to be in here.
I think I figured out what I did wrong.
Did you get it?
Well, I plugged in 5 and got negative 8, so I should have had that point on here. But I think
so,
my brain was just not working.
So, yeah.
I just didn't plot it right.
So, yeah, half the battle.
Yeah.
being able to interpret what you do. This one's just like the quiz I gave you. If you guys remember quiz 4 in class, plugging in the points, finding the horizontal asymptotes and the vertical asymptotes. I hate PDF thing here. So horizontal asymptote y equals 0 because my denominator is greater than my numerator. My vertical asymptotes when my denominator equals 0. I have 2 of those because I factored it. And my y-intercepts when x equals 0. So that just gives me some points. Right? Then I can also use the number line test at those interesting points to see am I above the x-axis or am I below it. So from minus infinity to minus 1, I'm always below the x-axis. I can't cross it. So my only choice is to approach it this way. I have to approach the horizontal asymptote, and I have to approach the vertical asymptote. And then from minus 1 to 1, I know I'm positive because I have the vertical asymptote in there. So I have to be above the x-axis. So my only choice is that, right? Then I have to cross at x equals 1. Either I cross it or I touch it and go away from it. Turns out since from x equals 1 to x equals 4 is always negative, I cross it. Make sense? Then I plug in 5. I'm always positive there. Or I can plug in any number greater than 4. I plugged in 5. Got that. Oops. I plugged in 5 here. And I got that was always positive. So I graphed that. Again, super hard to kind of grade these when there's nothing there. I mean, 11 points, 22 points. It was kind of hurt us on the low end there. You can see where you fall in the class. Grades are posted on Blackboard. I updated Blackboard Alex grade to what I had on Alex. Alex grade seems pretty low, so I don't know if you're just not getting your pies done or you're not getting your homework done, or if it's the in-class part, what we're doing, because that's 20% of your overall Alex grade. So this next section, I plan on giving you guys a lot more in-class quizzes or take-home quizzes, because I feel like the more I can give it to you guys and have you write it out and give you feedback, I think the better prepared you'll be for the test. That being said, Chapter 4 is probably the lowest performing exam in college algebra. So the third exam tends to be the lowest, and I don't know if it's because spring is coming and we want to get outside more and we don't want to be stuck in front of our computer doing whatever, or the material itself, it's really kind of hard to relate to because it's exponential and logarithmic functions, and not a lot of people have connections to that with the real world. What's it mean to be e to the x or ln of x, an inverse function? So I'm telling you now, you might want to spend a little extra time and be prepared for this test. That being so, I'm going to try to give you in-class quizzes that are just like the test. So, here's 4 or 5 inverse functions. Let's just practice every type we can. So then once you get to the test, it'll be like second nature, or I hope at least that way. We don't want to start with 4-3. Let's start with 4-1. Anyone have any questions at this point? Look over your exam, make sure the numbers come out correct. It's a little weird, but you should be able to add up all the points you miss. Add 3 to that. Divide by 80, and then that's how you get your percent. So if I did something mathematically incorrect there, please let me know as soon as you find that. 4-1 is a little bit of review. When we talk about one-to-one function, you guys remember doing that with relationships, if it's one-to-one or not. So we said a one-to-one function has, for every a and b in the domain, that f of a cannot equal f of b. Right? So looking at the answer key here. What this means here, for every input, there is only one output. They like fancy symbols. And They paid for math type, so they're going to use it. No, I don't know. Yeah, this is what it's saying though. For every A and B, if f of A equals f of B, that tells you A has to equal B. The easiest way to test that graphically is the horizontal line test, right? So if I can draw a horizontal line and it intersects the graph at more than one point, if no horizontal line intersects the graph at more than one point, then the function's 1-to-1. I don't know why on my answer key I say this is 1-to-1 here, but here you can see if I plug in -2, I get out 2, and if I plug in 2, I get out 2. So f of -2 equals f of 2, but -2 doesn't equal 2. So therefore, this is not 1-to-1. Right? Here, any vertical line, I only cross the graph once, right? My horizontal, I keep saying vertical, sorry. So this is not a function because it doesn't pass the vertical line test, but it is 1-to-1 relationship, right? Right, if I plug in f of 1, turns out I get 2 outputs, which tells me it's not a function, but it's still a 1-to-1 relationship. We're going to focus on 1-to-1 functions, right? This is a 1-to-1 function there. Technically, it's not a function. So, not a function, right? Because the vertical line tells you if it's a function. Do you guys remember that from the very first section we went over? So this is a function because it passes the vertical line test and it passes the horizontal line test. So it is a 1-to-1 function. It has to pass both to be able to find an inverse, and that's what we're leading up to. So this is not 1-to-1. This is not a function, and this is, yes, it is 1-to-1, and this is a function. So we're happy. We can find an inverse of this function. Now, not all functions have inverses, and that's what we're leading up to. This whole section is basically being able to find the inverse of the function. Don't get too caught up on the lingo because they will tell you this is a 1-to-1 function. If you know it's a 1-to-1 function, then the inverse exists. If they say this is a function, if it's not 1-to-1, you can't find the inverse. So a lot of times we have to limit the domain. You've taken trig, you might have remembered limiting the domain of sine, cosine, and tangent, have sine inverse, cosine inverse, tangent inverse. If you haven't, don't worry about it. But so graphically, we can show it's 1-to-1 if it passes the horizontal line test, and we can show it's a function if it passes the vertical line test. Algebraically, we can show it's 1-to-1 if f of A equals f of B and A equals B, right? So this is saying, well, what is f of A? Does that equal f of B? So 2A minus 3 equals 2B minus 3. This only happens if A equals B. And you can see an example where it turns out A can equal plus or minus B, and then we have a problem. Here, if I add 3 to this side, I add 3 to this side. If I divide 2 from this side and divide 2 from this side, I have A equals B. The only way f of A can equal f of B is if A equals B. You guys see that algebraically? I show that. But be careful because B is going to have a different relationship. So if I want to say what is f of A, compare that to f of B. A squared plus 1 equals B squared plus 1. So subtract 1 from both sides, and I have A squared equals B squared. If I take the square root of both sides, I have to take plus or minus. right? So if I take the square root of both sides, I have plus or minus a equals plus or minus b. So this is not 1-to-1. Because if a equals 2, and b can equal minus 2, so 2 squared equals minus 2 squared. This is true. 4 equals 4. But 2 does not equal minus 2. You guys see that? So this is an algebraic representation of 1-to-1. To show something's 1-to-1, you have to show f of a equals f of b only if a equals b. In this case, if I set it up, does a squared ever equal b squared when a doesn't equal b? Yes. In this case, I can just give a quick example. If a is 2 and b is minus 2, I plug them both in, 4 equals 4, but a does not equal b. So in that case, I could say, I could limit the domain to be 0 to infinity. Then I only have positive numbers here, and I can take the square root, and it would be a equals b because I get rid of the negatives. So you can force functions to be 1-to-1. And sometimes when I want to give you, or the book gives you a function they want you to find an inverse of, that might not be 1-to-1 on the whole real number line, they'll limit the domain from like 0 to infinity, so you can find the inverse. You can find the inverse, but it doesn't exist for all numbers, or it's a different inverse for different domains. So the first thing we're going to look at is determine where, if I give you two functions, show me their inverses of each other. You know what an inverse means? If I put in x and get out y, if I put in y in the inverse function, I get out x. Do you guys remember talking about that a little bit with inverse functions? So this is kind of what it's saying. It doesn't matter what order you do it in. If you look at the composition of f and g, or g and f, if you get out what you put in, say x, then they're inverses of each other. So let's look at this example here. We're looking at the cost to rent a kayak at a beach resort is a flat fee of $10 plus $5 an hour. The cost is in dollars. So f of x, this is how many dollars it's going to cost me, and x is the number of hours, right? But what if I want to know, I can find the inverse by finding the amount in dollars, and then the answer would be how many hours I spent. Here, if I know how many hours I spent, I plug it in this function, and it tells me my price. But I can find a function that I plug in the price, and it tells me how many hours I spent. That's the inverse, right? So the setup for inverse, and I'm going to write this out for you guys. So I'm going to find the inverse here, but here's the steps. The first thing you want to do is replace f of x with y. So you have y equals a function. Then you're going to switch x and y, the roles of x and y. Everywhere you have an x, you write y. Everywhere you have a y, you write x. And then you're going to solve for y, and that will be your answer. F of x, f inverse of x equals some function of x. So let's look at doing it for this example. We have g of x in this case. G of x equals x minus 10 over 5. Oh, they've already found the inverse here. We just want to determine if it is an inverse. So if I have f of g of x, I could write that as f of g of x. I prefer this writing because it's a little more straightforward that g of x is my inside function, f of x is my outside function. But your book could write it like this. So I'm going to take this g of x and replace it everywhere I have an x in my outside function, f of x, right? So I have 10 plus 5 times x minus 10 over 5. This is just confirming it is the inverse. Eventually, we'll actually calculate the inverse on our own. And that was the method of those 4 steps I jumped a little bit ahead of. So now if I simplify this, I have 5s are going to cancel, and I have 10 plus x minus 10, right? Which would give me x. And that is exactly what I want to show. And I could also do it the other way, g of f of x. And I would have 10 plus 5x minus 10 over 5. Do you guys see where that comes from? I take my outside function g of x, and everywhere I have an x in that, I replace with the whole f of x function. So this is f of x minus 10 over 5. I simplify that, and 5x over 5, which gives me x, which is exactly what I want. So this would be yes. This is an inverse. G of x is f inverse of x. What does g of x mean? Well, g of x is the number of hours the kayak was rented. X is the cost. F of x is the the cost, where x is the number of hours I rented it for. Right? So if I have the number of hours I rented it for, I plug it in f of x and I get the cost. If they tell me the cost, I plug that into g of x and it tells me the number of hours it was rented for. Do you guys see that? Input, output. For inverse functions, what you put in the function, right? You put x in the function, you get out y. If I put y in the inverse function, I get out x. Does that make sense? So to find the inverse function, here's our process. So let's look at the process for this inverse function here. Write the equation for the inverse. The first thing I want to do is write y equals 4x plus 3. My first step is to put y equals the function. The second step is to switch the role of x and y. So now I'm going to say x equals 4y plus 3. Now I solve for y. So I would have x minus 3 equals 4y, divide both sides by 4. Of x minus 3 divided by 4 equals y. My last step is to say this equals the inverse function. F inverse of x equals x minus 3 over 4. An inverse is undoing what the function did. So if I take a number, multiply it by 4 and add 3, and give you that number, if you take that number, subtract 3 from it, and divide by 4, you get the original number I had. That's what the inverse means. Graphically, it's switching the role of x and y. This point here is at 5, 2. But in the inverse function, it's going to be 2, 5. Right? What it means is if I put 5 into my function and get out 2, if I put 2 in my inverse function, I'm going to get out 5. Any questions on the process? The process is pretty straightforward. Algebraically, it's not that difficult, right? Y equals a function of x, switch the role of x and y, and solve for y. That is your inverse function. Write the equation for the inverse function for a 1-to-1 defined by this. So what is the inverse function? Well, first step, y equals 3 minus x over x plus 3. Step 2 is to switch the role of x and y. So I have x equals 3 minus y over y plus 3. And then solve for y. How am I going to solve for y here? I want to get y by itself, right? I want to get y out of the denominator. So what can I do to get y out of the denominator? Multiply by y plus 3. Be very careful when you do this because it's actually a parentheses. So I have to distribute that x to both terms, right? So the y plus 3 on this side is going to cancel. And I'm actually left with xy plus 3x. You guys see that? Now that's probably where the number one mistake in these types of problems come from. Students don't distribute that x. Equals 3 minus y. Question? Right, be very careful. These terms come together. So you have to distribute this x to both terms. So we get xy plus 3x, and then on the right-hand side we have 3 minus y. What do I need to do now? Subtract 3. I need to get y by myself, right? I have a y over here, and I have a y over here. Yeah, so if I subtract the 3x, and I add the y, I'm going to clean this up a little bit. I have xy plus y equals 3 minus 3x. How do I get my y by itself on the left-hand side? Factor out. I factor out a y, I have x plus 1. Right, I take a y out of this term and a y out of this term. Equals 3 minus 3x. Then how do I get y by itself? Very good. Divide by x plus 1. If I do that, that gives me y equals 3 minus 3x over x plus 1. And the very last step is to write that as the inverse.
Why didn't you, as the, whenever it's xy plus 3x equals negative 3 minus y,
Mm-hmm.
did you just add 3 and then divide it by a negative 1?
But you would have a y over here. You want to get y by itself. One y.
Oh, yeah.
Yeah, so yeah, you have to get all the y's on one side and then factor out a y and then what you have left. Some of you look a little confused. What are we getting caught up on? Did you understand this first step here? Y took y plus 3 on both sides. Okay, so then I got xy plus 3x equals 3 minus y. Subtract y from both sides, or sorry, add y from both sides. It actually does not matter which direction you go. If you put y's on the left or y's on the right, you're going to get the same answer. It might look different though. Another answer here could be 3x minus 3 over minus x minus 1. That could be a correct answer as well. Because if I multiply top and bottom by minus 1, it's the same thing. So it doesn't matter if you bring the y's to the left or the y's to the right. You guys work on this next one, very similar. Write an equation for the inverse for a one-to-one function defined by what's given. Step 1. Step 2. Step 3 would be solve for y. So just like we did before, we multiply both sides by y plus 2. Don't forget to distribute that x to both terms. Everyone get the sign-in sheet? Good. So now I need to get y by itself. So I need to put all the y's on one side and everything else on the other side. And again, it doesn't matter if you take the y's to the right side or the left side. The terms with the y on it, stick it all on one side. Then you factor out that y and see what you have left. Okay, so if you have xy plus 2x, y minus 2. So are you adding or subtracting here? Because you can't divide like that. You have to add or subtract.
So I just have 2 over here?
You could add the 2 over here and subtract the xy to this side. So you'd have 2 plus 2x equals y minus xy. And then you would have a y minus an xy. So if you factor out a y, you have a 1 minus x. And I'll write that. I just yeah. A common mistake here is thinking you can divide when you're adding or subtracting. You can only divide when you multiply. We lost a term here. So you have this, which is good. You see, that's y, that's this. So you have a minus 2x here, but you just have a minus 2 here. So multiplying both sides by y plus 2. That's the only way I can get rid of what's in the denominator. So I have xy plus 2x equals y minus 2. Now, I have 2 terms with y's in it. Whatever side I want to pull them onto, I can pull that onto. Typically, I always go to the left-hand side. I don't know if it's just, don't know the word. Tendency, because I always say y equals a function, but it doesn't matter which side you go to. Here, I'm going to pull to the left-hand side, so I subtract y, and I'm going to subtract 2x from both sides, right? So if I subtract y from the left-hand side, I have to subtract it from the right-hand side. If I subtract minus 2x from the left-hand side, I have to also subtract 2x to the right-hand side. Simplifying this cancels, this cancels. I'm left with xy minus y equals a minus 2 minus 2x. You guys see that? That's probably the most difficult step. Cannot talk anymore in this process. Now once you're here, you're almost there. The next thing is to factor out a y in all the terms that have a y in it. So I have an x minus 1 equals minus 2 minus 2x. The last step is, now I'm multiplying, so I can divide. You can only divide when you multiply. I can't divide by y anywhere else. because I'm adding or subtracting y. So this is x minus 1 divided by x minus 1. So this tells me y equals minus 2x divided by x minus 1. And then the last step is to actually write that as f inverse of x. If you would have went to the other side, you would have had 2 plus 2x over 1 minus x. That is the same answer. If you divide top and bottom by minus 1, you get the same answer there. So I'm going to give you guys a quiz to take home that has 4 of these problems on it that are just inverse, because I think the more you can get to practice these on this test, this is kind of where it's going to say find the inverse of this given function. So this will be due tomorrow in class. Next time I see you. No, tomorrow. Maybe Wednesday in class. It will also be posted to Blackboard, so if you lose it, no excuses. They're the exact same type of problem. B is a little different. Let's go over B real quick. Let's go over number B on the quiz real quick. I have k of x equals the cubed root of x plus 8. So the first step would be write y equals the cube root of x plus 8. What's my second step? Yeah, x equals the cube root of y plus 8. How do I get rid of that cube root? You take the third of both sides, right? So then that would give me x cubed equals y plus 8. And that's pretty much there. You guys see that? So don't be too intimidated with that. And the same thing on C. If you want to get x cubed by itself, you take the cube root of both sides. So they're very similar. The cube root of x is actually the inverse of x cubed. Right. If I take 3 times a number and give you that number, how would you get the original number? You would divide by 3, right? So multiplication and division are inverses of each other. If I take a number and add 5 to that number and give you that number, how would you get the original number? You would subtract 5, right? Addition and subtraction are inverses of each other. Right? Exponential and taking the roots, like a to a number and the number root of a are inverses of each other. So here it's saying if I take the cube root of a number plus 8 and give you that number, you would actually take that number, cube it, and subtract 8 to get the original number. And that's what inverses do. It undoes what the function does to get the original number out. So you can actually code things this way, plug it into a function, get out a number, give someone that number, give them the inverse function, they plug that number in the inverse function and get what you originally wanted, what you originally wrote. So practice. I'm going to nail you guys hard with this section with a lot of take-home quizzes and in-class quizzes. So when you get the exam, you know exactly what to expect from each section. All right? All right, I'll see you guys on Wednesday.
Gave me an extra